Hi guys, welcome to the first pre-recorded lesson. So today I'm going to go through electrons, neutrons, protons of an element and how to draw electron shells. Okay, so we know that in the nucleus of a shell, so a nucleus of an element, that's where you find protons and neutrons, and in the shells is where you find the electrons. So what you need to remember is that the protons and neutrons, they have a mass. They're actually heavy. So that's why it contributes to the uh, mass number of an element. So the protons and neutrons in a nucleus will tell you the mass of an element. The electrons are so tiny that they don't actually impact the mass number significantly. So um, they're the main things you need to know, which is given in a couple of slides coming up. So if we go to this slide here, this is carbon. Hopefully you have your periodic table with you. Remember the mass number is the bigger number. So the mass number will show the number of protons and neutrons when you add it together. The atomic number is the number of protons, so that's really important. Okay, this slide is also important, just summarizing things. So the atomic number of element is a number of protons. So in this case, there are 1, 2, 3, 4, 5, 6 of these, which means that is also known as the atomic number. The mass number is the number of protons and neutrons. So that is both of these here. We know that there are 6 protons and there are 1, 2, 3, 4, 5, 6 neutrons, which means the mass number is 12, is when you add them together. The formula that you need to know is that the number of neutrons, so to find out how many neutrons there are, you get the mass number and then you take away the number of protons. So we're going to do a couple examples to clarify this. So hopefully you guys remember this table. So if we look at potassium, potassium has a symbol K. Its atomic number is 19. The mass number has 39.1, but I'm just going to leave it, like I said, round it to the closest whole number. So I'm going to leave it as 39. We know that the atomic number is the same as the number of protons. So I'm going to write 19 straight away. Hopefully you guys remember that protons are positively charged and electrons are negatively charged. And they usually balance each other out. So protons and electrons in an element that has no charge would be the same. So if you've got 19 positive protons, you'll also have 19 negative electrons to balance it out. To find the number of neutrons, if you go back to the slide, the number of neutrons is by getting the mass number and subtracting protons from it. So the mass number here was 39. The number of protons is 19. So 39 minus 19 is 20. That's how many neutrons it has. Let's have a look at gold. So gold has a symbol of AU. The atomic number of gold is 79. The mass number is 197. So we know that atomic number is the same as the number of protons. So I'm going to write 79 here again. And the number of electrons and protons will be exactly the same, so 79. We know neutrons is, sorry about that, is mass number. Mass number was 197 minus 79, which is 118. So I would suggest just picking a couple of elements from the periodic table and trialing this yourself, and you'll get the hang of it straight away. Okay, the next thing is about electron shells. So we know that each element has electron shells, but the number of electron shells is different depending on the element. So in the first shell, so I'm just going to draw an element here. It's a random element that has 3 shells. The first shell can hold up to a maximum of 2 electrons. So it can hold a maximum of 2 electrons, nothing more. The second shell can hold up to 8, 8 like this. And the third shell can also hold up to 8 and nothing more. So at this level, you guys need to know just the first 3 shells. There are more shells and it goes into more in depth, but you don't need to know that for now. Just know that the first shell can hold up to 2, second can hold up to 8, and third can also hold up to 8. So let me just have a look at this example here. So this is sodium, Na. If we look at periodic table, sodium has the atomic number of 11 and it has a mass number of 23. And it says state the number of protons, neutrons, and electrons. So protons, we know it's the same as the atomic number 11. Electrons, we know that these two will be the same. I believe it is 11 as well. Neutrons, if we go back to our slide here, number of neutrons is the mass number minus the protons. So get back to our question. Mass number we know is 23 equals 12. And I've already given you what sodium looks like. So sodium, we know it has 11 electrons. So we know that the first shell can hold up to 2, second shell can hold up to 8, and the third shell can also hold up to 8. So the first shell will have 2 here. Remember that we need to have 11. So the first shell can only hold up to 2. Then we're going to go to the second shell. It can hold up to 8. So far we've got 2 and we've got 8. That makes 10. We need 1 more. That's why we go to the third shell. 1. And we know that 2 plus 8 plus 1 gives you 11, which is the number of electrons. So let's do some examples. Let's have a look at aluminium. This has the atomic number of 13. So when we're drawing electron shells, we just need to worry about the atomic number, which is the smaller number in the periodic table. If you want, I would suggest pausing the video now and try and attempting yourself, and then continue the video and check your answer. But otherwise, just follow along with me. So we know that aluminum has 13, has a atomic number of 13, which means that it has 13 protons. If it has 13 protons, then it also must have 13 electrons. So 1, 2, 3, 4, 5, 6, 10, 11, 12, 13. Okay. So if we were to draw aluminium, just rub that out. If we were to draw aluminium, okay, so we know the first shell can hold up to 2 and nothing more. If you want on the side, you can write this on the side just so you guys can remember. The first shell can hold up to 2. That's it. So we need to have a second shell. The second shell can also hold up to 8. So 1, 2, 3, 4, 5, 6, 7, 8. Let's see if we're done. 1, 2, 3, 5, 6, 7, 8. We still have 3 more to fill. So we're going to draw a third shell. And we know that the third shell can hold up to 8. So it can definitely hold the last 3. Oops, the last 3 like that. Cross these out. So the first shell has 2, the second shell has 8, and the last shell has 3. This is also known as the electronic or electron configuration. And if you add these up, 2 plus 8 plus 3 should give you 13. I'll do another example. Like I said, feel free to pause the video and try and do it yourself. Let's have a look at neon. So neon has the atomic number of 10, which means it has 10 electrons. So that's the nucleus. The first shell can fit 2. Obviously, we're not done. If we filled up 2, we've got 8 more to go. So we're going to draw another shell. And the second shell can hold up to 8. So the first shell has 2, the second shell has 8, and we know that 2 plus 8 gives you 10. So we don't need to draw any more shells. The first shell is completely full, and the last shell is also full. And that's how you draw it. I would suggest picking some examples in like the first 20 elements of the periodic table and trying it yourself, just to get the hang of drawing it, because this is something you definitely need to know. Another thing you need to know is the outer shell. The outer shell here is obviously the most outer shell. That is also known as the valence shell. And the valence shell will have valence electrons. So the electrons that are found in the last shell, or the valence shell, are known as valence electrons. So if we go back here, the last shell in aluminium has 3 electrons, which means that it has 3 valence electrons. It just means how many are in the last shell, or the valence shell. Alright, so that's it for this lesson. Like I said, please do examples yourself and see how you go, just so you get the hang of drawing it and understanding electron configuration. Good luck, guys!